Okay, we're just going to try to show the frequency or the waveform that's in the air. It's coming off, and this thing has been gaining voltage, by the way. It's just been sitting here. It was at 4.8, and then it's gone all the way up to 4.84, and it keeps hitting 4.85. So it's increasing in charge instead of decreasing from this battery pack. It's powering this stuff. That fluorescent tube is lit. You just can't see it because it's dim. So we're only at a low voltage, and most of the power is going through that light, the orange LED strip. Okay, this is sitting here showing that there's ambient energy or radiant energy. The pliers are acting as a good antenna because they're made of like a soft iron in there. It's a soft iron. It's just iron. So that iron is highly magnetic, and it's able to act as an antenna, like the human body acts like an antenna for the same energy, which is kind of interesting. I don't know exactly why that is or how that works, but we're going to show with this scope, just by going near it, see if we can see the waves. Yeah, we can, without even connecting either side. But let me see if I touch the black side. Okay, I'm touching the black side, putting this probe closer. You can see the wave coming off of here. What is it reading? Focus. 630 kilohertz. I don't know why it can't focus. Okay, 630 kilohertz is the wireless signal coming off of the secondary coil, the big tall one. Nice clean sine wave, perfectly clean. This is wireless. Okay, the end of that's just floating here in the air. There's not even like an antenna or a receiver connected to it. It's just, that is the antenna, the red side of the probe, and then I'm holding the black side, touching it. I'm grounding it to my body. We can see the sine wave. This is the same sine wave that these pliers are absorbing and acting as an antenna into these lights. Okay, now let's see if I touch these lights. They get brighter. Yeah. Okay, that made that go up too. See, that's wild. There we go. Oh, don't do this. Don't do that. I don't know if I even need this. Let's see. Disconnect this. Just. Oh, what do we do? Okay. Fuck this up. Here we go. Okay, watch this coil. See, there's the end. It doesn't go anywhere. It's not connected. It just goes to this green wire. And this green wire just sits here. Okay, one end of these two lights is connected to these pliers, and then the other, we're going to make another connection to this coil. And look at how bright that gets. Yeah, nice wireless power coming from that much voltage. All the way over here, it's receiving the radiant energy that's in these wires. It's in this whole system. And this is just making it light up pretty good. Let's see, it's getting my body is just going right through the insulated handle. It's like, what is it doing? If I put it inside there, what does it do? No, I have to touch it. Okay, or you can put it here and then it stays on. It's getting the radiant energy out of these wires. It's crazy, huh? But as you can see, this light is running. It's really bright. That tube is on even though you can't really see it because that light's washing it out. That tube is also on. There's radiant energy. We're just showing that with this. The voltage doesn't change. It's gone up actually from a little bit ago. It was at 4.8. So the voltage will not drop on the battery pack. It won't go down, which I'm pretty happy about. Okay, I'm just gonna leave it here. Show it again in a few minutes. It's not gonna change. Voltage check. Same. It's not going down. It's not getting used up. It's pretty awesome, I would say. Can't see that tube's lit. Oh well. I'll turn the lights out later. That's lit off of just the pliers and that coil. If I touch it, it gets brighter. Doesn't have to drain. is not budging. It doesn't have to change. That's wireless. That tube is wireless. You can't see it. That's wired. All coming from this battery pack. These are AA rechargeable little batteries. If I leave this light lit for hours and hours and hours, and then I come back and test these batteries and they're still absolutely full, that's not that normal. Seems like it's not that normal. If it doesn't ever go down even anything, not even 1/100th of a volt, then we're not using any energy up. It's just recirculating the same energy. That's pretty fun. That's pretty fun, I would say. Light show. The lights that never go out, the show that always goes on. You know? What's it doing? Voltage check. See what we got. Wow, it's the same. Isn't that weird? Isn't that kind of weird? It's the same voltage. We still got this wireless power and everything. I'm gonna show you this wireless power. Okay, we're gonna touch this board. Let me go out. Okay, touch the board here, fool. Look at that board. Come in here. Look at that, you know? That's crazy. That's crazy, my boy. That's so crazy. What is he doing? Oh, I messed with it. I better back up. I better back up. That's crazy. Where's my little crystals? Where are my little crystals? You know. Where's my little crystals? I want my crystals right now. What the fuck? That's outrageous. Same voltage. It doesn't ever drop. So something magical. Something is magical. I think I'm finally just gonna leave this on all night and just not worry about I was like a speck worried about a fire because it was increasing the voltage before, but now it just mainly always stays the same. So I'm just gonna try leaving it all night and see if it's dead when I wake up. Or if it's alive. It's living. Oh, you're spraying the water. Watch the water, you guys. No one's gonna ever see these videos. That's the worst part. I can't show anybody what's going on right now. You know, like what's going on right now? I can't show anybody apparently. I'm already flagged and censored. It's all over for me before it began. I can't show anybody nothing. Show nobody nothing right now. Is that in the frame? Just trying to show, I'll zoom out. Just trying to show that it just sits there while I'm doing stuff. Yeah, voltage 4.84. Yes. That's crazy. What's that voltage at? Let's check it out. Let's check it out. Oh, it just got higher for a second. Or is it going lower? It hit 4.85. What are you doing? Oh, because that thing is, I turned the washing machine on, or the dryer. Now it's vibrating some stuff. What are you doing right now? What are you doing with your voltage? What are you doing? We're 22 minutes in. 22 now. What is it doing down there? You know? It's getting crazy on me. You're getting crazy. I just need some tea right now for reals. Give me some teas. Jesus. It's so brutal. It's so See what it's doing. What are you doing? What are you doing? What are you doing? Oh, you broke it already. Don't break it, you know? Oh, the voltage climbed higher. How does it do that? Oh, it's the same. What is it doing? I don't know what it's doing. So I'd go higher for a minute. Is that gonna drain the battery now? I don't think so. So we're at 4.83, so if this happens to by any chance ever go back up above 4.83, well, this can only mean one thing. turn these lights out for a sec just so you can see the tube. Just so we can possibly see this tube. Turn all the lights out. That light is so bright that you can barely tell, but yeah, it's a purple tube, but you can't see it barely the way I can. That light is just blowing it out. The only time it went down from 4.84 to 4.83 is when I started touching some stuff in here. I'm just throwing it off a tiny speck. So we'll see if I just never ever touch this. It ever changes. I've already done this for like 6 hours. 6 hours, and then I checked the battery at the end and it was full. Literally actually full. It was 4.99 volts. Which is full. And then I went to have dinner and I came back and it was 5.05 volts, which is literally maximally charged. The charger only goes to 5 volts. The charger only goes to 5 volts. I'll show you real quick. These are EVL little batteries. The charger output voltage. Wait a second. Yeah, the output voltage. Whoa, it only goes to 1.2 volts. It only goes. Are you kidding me? I gotta turn that. I gotta see this. It only goes. It goes to. It actually it actually outputs. Why aren't you getting clear? Come on. It outputs 1.2 volts. I didn't even notice that. So that means when you put all of these together, there should only be 4.8 volts. It's 1.2 times 4. Which would be 4.8. 4.8 volts should be the max charge. Should be the max charge. And I'll just show you the batteries say right on them. Why is it so unclear? Let me turn this other light on. Come on. It says right on it 1.2 nickel metal hydride. Nickel metal hydride. 1.2 volts. So that means this thing only charges the whole. See, there's a 4 stack here, and then there's like another 4 stack here. So this 4 stack should only get charged to 4.8 volts. So when my battery, so it's full right now, is the point. But when I was finished doing this before, they were at 4.99 volts. And so if I disconnect these today again and they're still at 4.99 volts, then we're more than full, first of all. After running this for hours and days, we'll be more than full. So I effed those other batteries up at a certain point. They rapidly discharged in like a couple minutes, like in like seconds. So I put in a new fresh 4-pack into here today, and I've been running this thing for hours today, just doing the same thing again, hours and hours, and the batteries are still full. When I disconnect it from this load, the voltage will actually go up a little bit when it's not under load, and it'll be higher than full after running the load for hours. So think about that. It's insanity. It is insanity. In other words, every single one of these slots, each battery gets charged individually up to the level of 1.2 volts. That's its full max charge. That's its actual max charge, 1.2. It says right on here that that's as high as it will go. That is as high as it will actually go. The output voltage is 1.2 volts, period. So that means out of the input of 5 volts here from this 5 volts charger, that it will charge up a 4 stack of these, each to 1.2 volts. And all you do is when you stack them in series, you just get all their voltage adds up. So it's 1.2 as absolutely full times 4 gives you 4.8. So 4.8 volts is their actual theoretical fullest charge. It's their maximum charge. We're at 4.83 and it just stays full forever. When I disconnect this, it will go higher to like 5 volts. So just think about that. When I'm done running this for days at a time, it'll be more than full still. It's pretty shocking. Yes, me. It is shocking. Voltage check. Voltage check. What is it doing, you know? It's more than full and it doesn't go down. So what is it doing? This is such a simple device. It's so simple. It's crazy. It's crazy. It's crazy. I'm just gonna leave this on overnight and just hope there's not a fire, because I don't have a battery in my smoke detector. I just moved in here pretty recently and I forgot to ever. I kind of didn't want to fix it because I make smoke sometimes when or like cook in the oven or like season a cast iron pan, and I'm afraid to set it off, and there's a sprinkler system in here, and that's what I'm actually worried about. The alarm is one thing. I've just had a whole bunch of fire alarm trouble at where I was living. It would just keep going off randomly, and I think that might mean it just needs a new battery. But it's so loud, it's so annoying. It would always do it in the middle of the night. It was awful. So here, I just didn't put a battery in, and I'm paranoid that something could start a fire overnight if I leave a random experiment on, but I don't think it will be a problem at all. It just sits at the same voltage for hours. So either it's still on when I wake up and the battery's still full, or it's like dead. It's gotta. But judging by the fact that I can let this sit for 6 hours here, if I sleep for 8 hours, it's going to be the same. It's going to be full. Therefore, what I've discovered here is actually PE or FE. Figure out the acronyms. Perpetuals and freeze. If you say these words, I'm getting so triggered on the algorithm, they're going to F me over. Probably gonna send out a hit team on me. Well, so this is actually saying 4.83 volts under load. That's what it says under load. So it's fuller than fully charged while it's under load, and after hours of being under load, figure that out. So much more experiments I'm going to do. I've made white lightning from the earth before. Giant, insane white lightning from the earth, and from a device that only uses a few milliamps. Impossible. I made thousands of X gains. I don't know exactly what happened. I have to try to figure out what it was, but it breaks a device. I have to buy this device to do that experiment. It's $150 a pop. Maybe I can get them cheaper from this one source. It's $150 a pop. Oh, you're starting to cycle on me. Look at what it's doing. Is it just from vibrations? It started to go down to 4.82. I don't want you to do that right now. Don't do it. Don't even do it. I mean, we're 42 minutes into this. This orange light is being powered the whole time. It's just the reality. It doesn't seem like there's that much light in there, but actually there's like 200 LEDs on there, and when I turn it up to around 7.5 volts, that's where I usually use it at like dinner time. And it takes around 2 to 3, it takes somewhere between like 2 to 400 milliamps to run that. At this voltage, I'm sure it's obviously less, but still. Is it just so hyper efficient that it's still, I don't know, I just need to let it sit for days. We'll see what it does at this point. Like an hour into this, 45 minutes. We'll see what it does. The full charge on these batteries is 4.8 volts. It can have a surface charge up to 5 or even 5.1, but that's basically just a surface charge in that the full charging that these go to is 4.8. So we are still literally over the level of full charge. We've been running these lights for 46 minutes. Let me turn this one off. So we've been running this 12 volt light strip for 45 minutes right now, and that tube is on even though you can't see it that well. It is actually lit. We've been running that for quite a while, and this video has been 47 minutes right now. And the full charge on this battery pack is 4 AA 1.2 volt nickel metal hydride EBL batteries. Rechargeable, brand name is EBL. Nickel metal hydride. These are 1.2 volts per cell. AA size, 2800 milliamps. We've been running, it's a 4-pack. The max charge is 4.8 volts. The charger will only charge these to 1.2 volts each. That's full charge. We've been running this for 48 minutes now. Right now. 48 minutes. And the batteries are still over more than full. They're still more than full. It was at 4.8 at a certain point, and then it went up to like 4.5, or it went up to 4.4. So it went up while it was running these lights and that tube, and like I was just showing there's wireless energy all over here. I can take that off again and just show it. Let me show this one real quick. Okay, there's wireless energy here still all over. See, when I get near it, the voltage can increase. It's fascinating. Let me do this. What if I leave this here? Oh, that didn't necessarily like that. Take it off. Just showing that there is, in fact, wireless all over the place out here. Set this here, it kind of likes to be here. The iron of these pliers is acting like a nice quality antenna on one end, and then the other end is just going to this coil that I don't think is even necessary. Let's unhook it from this coil, and we're going to see if that changes the brightness or not. 3, 2, 1. Yeah, it doesn't need this coil, so all it needs is just the wire on the other end. Goes to nowhere. So there's just a wire on one end of this. Is a wireless circuit, I'll call it. This is 0 wire energy because it doesn't need even one wire like Tesla 1 wire. This doesn't even need one wire. This level of low power radiant energy this is wireless. So it just has one wire here that goes nowhere, and then a pair of pliers that go nowhere. Let me get that off of there so you can see that's all that's on here, and it's just showing the radiant energy that is coming off of everything in the circuit. All the wires, the batteries, they're all giving off radiant energy, and I think that's why the battery never goes down. It never really gets drained because it's being filled with radiant energy the whole time it's connected to the circuit. And I don't even have diodes on the receiver cables. See, there's this red one that goes nowhere, or no, it's touching that metal plate. That metal plate is not connected to anything. It's just wirelessly receiving from this coil. That copper plate is just wirelessly receiving. It's connected via this little spot right there, which it's kind of stupid. Let me just take this off of here. See, that made it go down a speck, but we're gonna clip it to there. It didn't make a difference. $52 minutes almost. In 5, 4, 3, 2, 1. 52 minutes in, and their battery is still more than full. 4.8 is the full charge. We are still over 4.8 volts. I wish you could see that tube is on. It's pretty cool. But mainly we're powering this light strip here just to show. It's because I need a load. I can do this later with this other light that's like super bright. I have a 20 volts green LED that's freaking insanely bright. It can go so bright it could blind you. That's a pretty decent load. We could power that one with the same voltage. So we're just letting this sit here and it never goes down. Hard to believe, honestly. This battery's getting low. Just showing how long this runs for, and it doesn't ever drain anything. I can't get this in the shot. Oh god. There we go. To do it sideways now because I'm charging it. Yeah, it's still at 4.82. .82. It doesn't need to use up this battery. I can't wait to connect this to a higher voltage battery. It's going to be awesome. Awesome. 4.82. It's like you can go for just... All I can do is let it go for days at this point and just forget about it. Just let it go for days. The problem is it's on my freaking only table. Oh shit. I gotta get some tables. I'm showing you the voltage. I gotta get some tables to Laser Saber would love this. Mal with MTech, you love this. I hope you see this soon, buddy. Hope you see this soon, Mal. Hope you see the other ones at least. There's gonna be a bunch of these. This one's like part 5 now. Like a 5-part series. Oh, crap. .82. It doesn't budge. How is that possible? You might wonder, how is it possible? How is it possible? 4.82. No draining. I mean, that would mean like this whole thing's being run. Oh, it's going to 4.81. Why would you do this? I guess we'll leave it all night and see. Oh. Which part? Wait, which one? Wait, what's... Okay. Voltage check. Look at that. We didn't actually go down. We just have some bad little connections. It's still at 4.82. We're now at an hour, almost an hour and 7 minutes. The voltage is the same. Is there an explanation? I don't know. Thank you, Jesus. And now in the next video, we're going to show how fast just that one strip light, without any other wireless stuff, just how fast that one strip light will actually take down this battery pack. Radiant energy coming off of the system. It's just self-charging itself while it's operating. So what it appears to be, if I just put some diodes on here, on those antennas wires, that one and this one, then that might make it even work better. I would imagine it would. Why is this so finicky? What is it doing? Guess I'll just leave this all night. That'll settle what's gonna happen. Oh, it's went back up. Oh my god, it did. You see that? It went back up to 4.82, which is defying physics. It's just a battery pack. It can only go down, so the idea that it's going back up now is awesome. It is awesome. I'll be back in a few. I'm just gonna let this sit. Don't fall, just hang out. What the heck? Oh yeah, just by me stepping on the floor is messing it up. Just every little vibration is actually screwing it up because the wires are like not even connected. But what's the worst connection here? What's the one that's really, why is it so bad? It's this side. It's just a really crappy connection, but it's still operating. There we go. What is making you weird? What is going on? Look at this, look at this. It's cycling up. It's not going down. It's just staying the same. 4.82. is this such a weak connection? I can't quite figure this out. So trippy. Yeah, it's totally cycling back up. Are you gonna do it? Yes, you're gonna do it. It's cycling back up to 4.82, where it wants to just hang out forever. Four 4.81. 4.82. Yeah, it's still like cycling around. That's weird. This only stays lit if it's over here. That is weird. 4.82. 4.82. Okay, we're an hour and we're almost 18 minutes. So an hour and 18, 3, 2, 1 now, 118. And we're still at 4.82 volts. Figure this out. .82. That's awesome. that's still at 4.82, I'll be pretty surprised. It'll be pretty wild. Still on. Let's see. I'm not even looking first. I'm just gonna film it first. 4.81. Oh. We're at 1 hour and 32 minutes. Oh, that connection is coming out. No, that's fine. Oh, I jacked it up. Let's see. We're at 4.8. See that tube goes out and then it lights on its own when I release that. See, when I do that, well, no. This is putting out wireless field the whole time. Let's see what happens if I put this up here. Whoa. Wait, that light got a lot brighter. The fluorescent went out. All those lights are on. We're at 1 hour and 36. 4.8's been my average. 4.82 I was at for quite a while. Like an hour plus, like an hour and 20 minutes. That's cool. That's not dimming out. That's not dimming these lights. It's the radiant energy effect. It gets really bright when I take the tube out of the picture. It changes the voltage because there's a higher load. But when I put the tube here, it always seemed like, see, that brought us back to 4.8, but this light got dimmer. 4.81. I don't know. Back to 4.81, but that light is a little bit dimmer, so there's less of a load, but that fluorescent tube is lit. You just can't really see it. That fluorescent tube is in fact lit. Let's see if I can show it any better. It's hard to see that it's lit, but it is. I've been at this level for hours. This video is 140, almost 143 minutes. We were about 4.82 the whole time. Right now it's reading at 4.81. This light, the orange one's been on the whole time. It's wired directly. That fluorescent tube is a UV tube. You can't really see because that orange light is so bright it's washing it out. But if I go turn the other lights out for a second, you can see. I'm going to turn this light out. Turn this light out. Turn this light out. See, you can see it. That tube is lit. It's just not that. See, you gotta hide that one. The tube is lit. It's a UV tube. It's supposed to look blue. It's just lit dimly, just demonstrating the wireless effect that's here the whole time that I'm not really tapping into. I don't have a resonant receiver or a bunch of resonant receivers that I'm using yet to tap into the wireless field. Ooh, look at that. We just went up. I show in these other videos all the wires. Just skip through. This is like going to be a 4 or 5 part series. You can fast forward, you can skip through all of this. You can look through all this to see the wires. There's nothing hidden under the table. There's no other wires than those 2 power cords that aren't plugged into anything. The only cords on this corner here, you have 2 from this meter, which is at 4.82. 2 from this meter. Comes down, goes up to here to the battery pack. This is a 4-pack of 1.2 volt rechargeable 1.2 volt rechargeable AA nickel metal hydride EBL 2800 milliamp hour. And for sure, the voltage should have dropped by now, and it's not. That tube is lit wirelessly just to show that. Okay, these lights are wireless, and they light up when I get near the circuit, especially 4.82. Okay, this is radiant energy. If I put it near these wires, it lights up. If I put it near the meter, because it's connected to the circuit, it lights up. Just let those sit there. 4.82. That tube is lit, just not that bright. Just demonstrating that there is still wireless energy here. Okay, we're almost at 1 hour 47 minutes. I've done multiple of these videos. That light is on. It's not even that bright compared to when I take that fluorescent tube out of the picture. Then the orange light gets a lot brighter, like 30% brighter when I take that tube out. But that tube is demonstrating the wireless effect, the powerful field that's here the whole time that I could be tapping into with resonant receivers. And also having that tube near there might be doing something. Kind of seemed like, let me turn the lights. It kind of seemed like it might be doing something to help the battery pack stay charged. So it's wild. I gotta go to bed real soon here, but probably just gonna leave this all night tonight. Problem is, it's not, the wires are loosely, haphazardly connected at the moment because I'm in the prototyping stage. And if I knock around, if there's vibrations, it can make it come a little bit loose. But as you can see, we're at 482, and that's where we started. The main bottom line here is when I'm done doing this and I disconnect this little battery pack and I check its voltage again, what's going to happen is it's going to be full. It's still going to read about 5 volts. It might read like it's going to be, it's going to be somewhere between 4.8 and 5.1. And that is, 4.8 is considered a full charge. 4.8 volts is a full charge because the battery charger for these batteries, where is it? By the same company, the EBL charger. You see, those are the same batteries. And on the batteries, it says 1.2 volts. Okay, 1.2. And on the charger itself, it gets a 5 volt input from here. Five volt input. this outputs 5 volts. And then this baby takes input 5 volts and it puts out 1.2 volts. 1.2 volts. And it charges AA or AAA. So what you see here is each one of these slots is a 1.2 volt slot. So each one of these batteries will charge up to 1.2 volts. So if I have 4 of them stacked in a case, then it's in series, then you just simply add those voltages up. 1.2 times 4. 1.2 times 4 is 4.8. So the full charge of a 4-pack in series is 4.8 volts. It's 4.8 volts. So after an hour and 51 minutes here, an hour and 51 minutes of powering that bright orange 12 volt LED light strip plus that tube, plus that fluorescent tube, which is dimly lit, but it takes a lot just to light that, and showing that it's getting that wirelessly. It's just sitting there. That it's sitting in is just a little base for it. I've showed it in different positions, and it doesn't, when it's close to the primary, it just seems to help. If I take it out of there, then the orange light does get brighter. It gets real bright, so it's like nice light. But when I put the fluorescent tube also in the picture and it turns on, it goes under load, the orange light gets less bright, but the fluorescent tube is lit, and it's just showing that there's this wireless field that I can be tapping into with resonant receivers. And it seems like it might help to have that tube there. It kind of seems to help the voltage stay the same forever. Like there's some kind of a talkback resonance between that tube being lit in proximity. Because normally when you put something in proximity, it can detune it and like mess it up. But with the fluorescent tube, and probably with like neon tube, these gaseous tubes, there can be an effect. In fact, with with like cold cathode tubes or like neon tubes, there can be an avalanche type of effect. So that's going to be what I do next, is I'm going to be getting some of those kind of tubes. But even this tube might be doing a little something with like an avalanche type of effect. All I know is that when I use that tube with this setup, it stays at the same voltage like forever. And if I take that tube out, it might very, very slowly start to go down. I'm not sure yet. I just keep filming it with the tube because it just works like this. And the voltage just stays the same. So yeah, I might just go to bed with this on all night after doing this for hours first. And if I keep it on all night, I'll just do another video in the morning and show where it's at. If it's still at 4.82, I don't know what to say. Just showing that that tube is lit. 100%, it is lit. And that thing obviously is lit. It's a 12 volt LED light strip with I think over 200 LEDs on it, that I was initially just using as like a resistor going into the primary coil. But it ended up being like I can actually put other stuff into there. I can probably use this to charge a battery like over there while keeping this first battery full. That's kind of where I think this is going to go, and then I might get in trouble. So we're just going to probably let this go to like 2 hours again. We're at 150, almost 155, 1 hour and 55 minutes. Continuous runtime with no degradation of the voltage in the battery, which means it's not being drained. It is not being drained. Okay, this is the 4th or 5th part, and I've showed repeatedly the wires that are here. It's messy, and I'm going to be doing this again with a way cleaner setup. I've showed this a bunch. I'm getting way too tired to keep doing this. I've been doing this for hours. Oh, you're starting to cycle. That was just from me like stepping near it, maybe. From the vibrations, because my wires aren't really connected right now. Literally. Next project is to make this into a little thing. I'm going to basically take this, once it gets fully charged, I'm going to take this fully charged 4-pack, and I'm just going to connect it directly to that light strip. Just directly connected off a battery pack to that light strip. And we're going to see how long it actually takes for that to drain the battery compared to doing it like this, where for hours and hours at a time there's no degradation on the battery. We're coming up on 2 hours and we're about the same voltage where we started off of just this little battery pack. Now maybe this is taking a lot less current than it seems like, but I use that with the DC power supply, and it takes like at least 100 milliamps. We're at 4.8 volts. So if I just connect it to a power supply at 4.8 volts, I'll do that later and show the exact milliamp draw on DC of what this light will take. And so this is a pulsating frequency, but I don't know, because that light is actually connected directly. Yeah, that light is actually connected. One side is connected directly, the black side is connected directly to the battery, but the red side has to go through this whole little circuit. Anyways, this is crazy. So we're at 2 hours now. 2 hours. And the battery is still full because 4.8 volts is a full charge. 4.8 volts is a full charge. 4.8 volts is a full charge because these are 1.2 volts, and the charger right on it, it says it only charges each cell to 1.2 volts. It only charges each cell to 1.2. I've already showed it. I'm just going to show it again. The output of this charger is 1 point. Come on, why can't you read it? It's 1.2 volts. So each one of these cells gets charged up to 1.2 volts. You stick 4 of them together in series, you get 4.8 volts with 2800 milliamps. So that's a 2800 milliamps for an hour. You don't actually get that much. That's like the whole theoretical capacity, but normally you can't use that much of it. So 4.8 volts is a full charge, and we're actually over that, and we've been running this stuff for 2 hours. I mean, now more than 2 hours. And it's been here for basically the entire time. When I mess with it, it gets a little weird, it gets a little wonky. Like eventually after hours, it goes down like 1/100th of a volt. I don't know what to make of it, but yeah, we're not yet running any kind of a tuned receiver. I don't know, there's so much crap in here right now. Let's see what happens when I put this pancake up around here. If it does anything. Put in a pancake. Does it make any difference if what happens if I disconnect this one? Ooh, what are you doing? Oh, see, that tube just got brighter. Why did that happen? The tube got a little bit brighter. It's hard to see it like this, but that tube just got brighter. I wonder what just happened. So now it's a little bit different. Let's connect this to here.